Somewhere, beyond everything we can see, there might be another universe. Not a planet, not a galaxy. An entire universe, with its own stars, its own laws of physics, maybe even its own version of time. And according to some of the leading theories in modern cosmology, that universe might not be sitting quietly in some far corner of existence. It might be moving toward us. So the question isn't just, is there another universe out there? The real question is this: what happens if two universes collide? Let's find out, because the answer might already be written across the sky. Before we talk about a collision, we need to understand what scientists actually mean when they say multiverse. This isn't science fiction. It comes from a real mainstream idea in physics called eternal inflation. Here's the basic idea. Shortly after the Big Bang, space expanded incredibly fast. But some physicists believe that expansion never fully stopped everywhere. Instead, it kept going in most places, while small bubbles, like ours, stopped expanding and formed their own separate universes. If that's true, our universe is just one bubble in an endlessly expanding sea of other bubbles, each one a separate universe, each one potentially governed by different physical laws. And bubbles, by definition, can touch. So what would actually happen if two of these bubble universes collided? Physicists who study this, including researchers at Stanford and Perimeter Institute, have run simulations to find out. According to these simulations, a collision between universes might not look like an explosion at all. It could instead leave behind a disc-shaped imprint, a subtle disturbance stamped onto the fabric of space itself. If our universe collided with another one in the deep past, the impact wouldn't necessarily have destroyed us. Instead, it might have left behind a circular signature in the cosmic microwave background, the faint afterglow of the Big Bang that still fills the sky today. In fact, some scientists have gone looking for exactly this kind of scar. This is where things get genuinely unsettling. Back in 2010, and again in later studies, researchers analyzing data from the WMAP and Planck satellites flagged several unusual circular patterns in the cosmic microwave background. These regions were colder and more uniform than they should be if the universe formed the way our standard models predict. Some scientists proposed a bold explanation. These could be bruises, leftover marks from a collision with another universe billions of years ago. To be clear, this remains a minority position, and most cosmologists think these anomalies have simpler explanations, like statistical noise or foreground contamination from our own galaxy. But the fact that this hypothesis is even taken seriously enough to test tells you something. The idea of a multiverse collision isn't just philosophy anymore. It's a testable, falsifiable scientific claim. And that changes everything. Here's the part most people don't expect. According to some models, a bubble universe collision happening today, nearby, might not necessarily destroy everything. Because both universes are expanding, the actual wall between them could move at or near the speed of light. That means if a collision boundary were heading toward us right now, we might get zero warning at all. Some models suggest it could arrive at the speed of light itself, meaning the light announcing its approach and the boundary itself would reach us at essentially the same moment. Some models suggest the boundary could rewrite the laws of physics in its path. Different particle masses, different force strengths, maybe even a different number of dimensions. In other words, not necessarily an explosion, possibly a replacement. The universe on the other side of that wall might not look like ours at all. It might not even allow atoms, chemistry, or stars to exist the same way. So why does any of this matter if we can't detect it coming? Because this theory does something rare in cosmology. It makes a prediction we can actually test. Scientists can search the cosmic microwave background for these circular bruises using increasingly precise telescopes, including future missions designed to map the early universe in far greater detail than Planck or WMAP ever could. If those scars are ever confirmed, it wouldn't just prove that other universes exist. It would prove that our universe has a history before the Big Bang. one possibly shaped by contact with something else entirely. That would be one of the most significant discoveries in the history of science. We don't know if we're alone in existence, not just as a planet, but as an entire universe. But for the first time, scientists aren't just imagining other universes. They're looking for the bruises they might have left behind. If you want to understand what's really out there, beyond galaxies, beyond light, beyond everything we can measure, subscribe to Deep Space Files. Because some secrets are written in the coldest corners of the sky.